Hello everyone, this is Aditya Pandey, and thank you for the opportunity to present me and my problem solving skills. Here's the question: House robber. It is a medium level question, and let's study it. So, you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into the same night. So, what does this mean? So, if you let's have through the example, like through the example that 1 2 3 and 1, let's say if you rob house number 1, then you can't rob house number 2 because the police will caught you. So given an integer array representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So that is the question, that how much I can rob tonight. So so 1 2 3 and 1. So as I can say that I can see that what I can choose. Let's say I choose 1 3 and nothing, because if I choose 3 and then choose 1, then I can't choose it because uh, it will alert the police, and the total sum of this will be 4. So let's see another possibility, which is if I will choose 2, then I have to choose 1, because I can choose 3, then it will be 3. So calculating the maximum, we'll get 4. Similarly, 2 7 9 3 and 1. So it is, let's say I will choose 2 and then choose 7, because I could not choose 7, then I have to choose 9 and then choose 1, then the whole output will be 12. Let's see another case. If I will choose 7 and then choose 3, then I will have 10. The maximum is 12. So so what I am getting is that if I could choose first, and if I can sum the whole array by having a space of 2 index, then I could get my answer. But it is a medium level question, and let think of another case. Let's say, hmm, let move to my copy. So I'm going to optimize this solution using dynamic programming. So what dynamic programming says that why to calculate the solution which is being already derived. So instead of deriving that particular solution, we just store it and basically send whenever the calling function calls it again. So what we can do is we can use a integer t, which is an array of name t. Basically, we can store our solution in this array, and and basically we can skip the recalculation of the recursion. So what we are doing is we are putting t, we are putting integer t equals to new integer at the main, and passing that t integer array to our recursion solution function. So what we can do is, if t of index is not equals to -1, what we are doing initially is we will be putting -1, so that the solution could be 0, right? So initially we are putting -1, a dummy value, so that we can identify that till now this section has not been calculated. So what this if check sees, that if my index is not being if it is being calculated, then return t of index. And here also we have to send a t, and here we have to send t of index.
Also, I would like to tell that this proper technique is also called memorization, because TP depends on two technique, which is top down and bottom up. Top down basically uses memorization technique, and bottom up uses for loop technique, which is the most optimized version. Let's try to memorize. Let's see if our memorized solution works or not.
So coding that recursion solution, let's refresh this. So static int solve integer index if index is greater than equals to nums dot len. This is the base case and we are returning 0 over here. For int I equals to index I is less than nums dot len and I plus plus. What we have to so what we have to do in this for loop, basically we are checking all the choices, and from these choices we have to return the maximum of it. So int max equals to 0, max equals to max dot max of nums of I plus calling the recursion solve of nums I plus 2 comma max return max, and int answer equals to solve of nums and 0, and what we are returning is answer. So let's check if it runs or not. It does. Let's check if it submits. Yeah, we get a TLE. So now we have to optimize this solution. Let's move to the copy.
So, as I have explained the problem before, which is house robber, these were the test case which were being given in the lead code. So, the test case, the problem was I could rob a house if it is not adjacent to the previous robbed house. So, let's say moving to the test cases 1, 2, 3, and 1. If I could rob 1, then I could not rob 2. So if we drive through the problem, then 1 and 3 could be robbed. So 1 plus 3 is equals to 4, and 2 and 1 could be robbed. 2 plus 1 equals to 3. So the maximum is 4, and the answer which is being given in lead code is also 4. Next test case is 2, 7, 9, 3, 1. Let's say I rob 2, 9, and 1. So 2, 9, and 1. 2, 9, 10, 11, 12. And 7, 3. 7 plus 3, 9, 10, 11. Sorry, 10. So these were the so taking a maximum from it, which is 12. So answer is given 12, and it is also in lead code. But if we make another test case by ourselves, which is let's say 2, 1, 3, and 5, and try to make it from try to maximize it. So 2, 3, 2 plus 3, which is 5, and 1 and 5, 1 plus 5 equals to 6. So the maximum from it is 6. But if we take 2 and just 5, it is 7. So here we can see that the approach of taking odd even indexes is failing here. So thinking on this problem, we can see that we have choices in robbing of houses. So let's say at every index I have some of the choices to rob the house. For example, let's uh, before Before moving through it, I would like to tell that whenever there are choices, whenever there is being choices, then there would be surely a recursion. Means if there are choices, then then there is a highly chances that recursion will be the approach, because recursion is all about choices plus decisions. The choices we have and the decision what we will be taking is recursion. So let's see through the problem. If I would have, let's go through my test case only, 2 1 3 and 5. Let's say I choose 2 at initial point, and after taking 2 as an after having after choosing 2, what the probably choices I do have, because I could not take I will be starting from I plus 2 index. So the choices I will be having will be 3 and 5. So what I can choose, I can either choose 3 and I can either choose 5. Let's say I choose 3. So on choosing 3, what would be the next choice? Then it is 0 1 2 and 3. 2 plus 2 is 4, and it is going outside the bound, so it will return over here. So it will return, let's say it will return 0, and it will return 3 and 3 plus, and here it will return 5. But before returning this, we'll be checking what is the so what if we'll be choosing 5. So if I will be choosing 5, then what will be the answer? Then it would return because it will go out of point, because it will move the index to I plus 2, and it is initially 3, then it will be 7, and it will be returning that. So it will return 5 here. So if we check which is greater, 3 or 5, it will return 5. So returning 5 here, and 2 plus 5 is 7. Now we can't rely on this index, we can't rely on this index only, because a single check doesn't verify the maximizing thing. So similarly we'll be checking for 1 3 and 5. And if I will like to code this up, then what I can write? So static and solve, let's say, because I have to return the maximum number, so I will be doing that. So integer nums, and let's say int index. So what would be the base case? Understand by yourself. If I will be surpassing the index, or I will be equals to the nums dot length, then it is the returning point. So if index is greater than nums dot length, then what I can do is I can return a 0 element. Other than this int maximum, we have to make a int maximum, because every time at particular call we have to see which is the maximum number from it, and then we have to return it. So int maximum for int I equals to 0, because why we are using for loop? Because we don't know how many choices are being there, that's why we are using for loop. For int I equals to index, and I is less than nums dot length, then I plus plus. And what we have to do is we have to maximize it. Max equals to mat dot max, then nums of I plus solve of nums and I plus 2. Here is the catch. We in normal template of recursion we just send I plus 1, but here is the catch that we have to send I plus 2, because the adjacent house we can't drop. So about it, and plus solve nums of I, and we have to compare it from max. Then we have to return max, and that's all about the recursion. Let's code this.
So let's optimize the particular problem. So what we have done in the copy is we are making an integer t, and we are making an array and putting -1 value in the whole array. I is less than equals to n I plus plus. What is n here is num start length plus 1, and we can do is num start length and t of I equals to -1. We are initially putting -1 as a dummy value in our array, and now sending it to the recursion function. Here t t of index is if t of index not equals to -1, then we have to return t of index. So what we are doing here is basically we are returning if the value is being previously calculated at that particular index, then we have to return that particular index. We will not calculate again. T of index equals to max. Here what we are doing is basically storing that particular value which we have been calculated. Now changing this recursion function, comma t, and let's see if it works or not. If it works, let's say submit it. And you can see that it is 100%, it beats 100% and works in 0 millisecond, and it is the perfect solution. So thank you. Have a nice day.